Okay, so at the end of the last video, I asked you to try to work on this problem. So hopefully you've done that, and you're just checking your work with me now. We're trying to find the area between the x-axis and y equals cosine x over the interval from 0 to pi over 2. Okay. I'll just point out cosine of x is a function that takes on negative values, but it doesn't take them on over this interval. So we're okay with having a non-negative function here. Okay. Now, we were going to find R3, so that's using right endpoints as our sample points, and we're going to use a regular partition. So I like to have a picture of just the partition. I'm going from 0 to pi over 2, and I'm chopping that up into 3 equal pieces. Okay. So the length of each piece will be my delta x, which will be pi over 2 minus 0, the length of my interval. Now, obviously, I can subtract 0 in my head. I'm just writing that down so I don't get in the habit of thinking it's just take the right endpoint and divide. It's the length of the interval and divide, and I won't necessarily always be starting at 0. Okay. And I'm dividing that by 3, so that's pi over 2 times a third, or pi over 6. Okay. So I'm just going to count over by pi over 6. So I get pi over 6, then 2 pi over 6, which would reduce to pi over 3, and then 3 pi over 6 is pi over 2. So these are my endpoints. I can go ahead and fill them in here. Here's pi over 6 and pi over 3. So you'll notice that neatly chops this into 3 subintervals. Okay. Now, I like to create a table of values for things. So I'm going to list my right endpoint and then my function evaluated at my right endpoint. Okay. So if I'm looking for right endpoints, the right endpoint of that first subinterval is pi over 6. So 0 is an endpoint, but it's not a right endpoint of anything. It's the left endpoint of the entire interval. So pi over 6, pi over 3, and pi over 2 are going to be my sample points, my x values. The function at pi over 6 is cosine of pi over 6. That's root 3 over 2. At pi over 3, it's 1/2. And at pi over 2, it's 0. So drawing the picture, forgot to specify that I wanted you to draw the picture. I hope you did. Okay. I come to my first right endpoint. I come to the height here. I'm extending that across the entire interval. So it's always that's the height over this entire subinterval. So there's my first rectangle. For the second subinterval, I come to pi over 3. I come to the height there. I extend that across the entire subinterval. And then for pi over 2, that's going to give me a degenerate rectangle. That's going to have 0 height once again. And I can see, in this case, I'm getting an underestimate again. All of my error is that I didn't count some area that I was supposed to count. In this case, if I had used left endpoints, I can see I would have gotten an overestimate instead. So my choice of sample points does affect what estimate I get. What's kind of neat is when I take the limit, it all goes away. It all goes to the same thing. So the estimates, if I stop with a finite number of rectangles, those will be different depending on how many pieces I use and what x values I choose for my sample points. But once I take the limit, I'm going to get the same answer whether I used left endpoints or right endpoints or some point somewhere in between. Okay, kind of cool. So let's go ahead and write out what we get. So R3 is just a sum of these 3 rectangles. I kind of like to have a picture. Okay. So this first rectangle, the height we said was root 3 over 2 times pi over 6. Plus this one, the height was 1/2 times pi over 6. Plus this one, the height was 0 times pi over 6. So notice all of these bases here are pi over 6. Pi over 6 happens to be the x value here. I don't care that it's the x value. I care about the distance. I'm multiplying by the distance or the length of each subinterval. Okay. And this, of course, had a height of root 3 over 2 and 1/2 and 0. Okay, just like last time, because we used a regular partition, I can go ahead if I want and factor out that common base. Let me clear a little bit of space up here. So that's going to give me pi over 6 times the sum of the heights, root 3 over 2 plus 1/2 plus 0. So that's going to be pi over 6 times root 3 plus 1 all over 2. I'm just going to leave that as pi times root 3 plus 1 over 12. That would be my right endpoint approximation for this particular function.